All right. Hello, everyone. Welcome back. Math 154. This is week 4. Lecture 1 should be our 7th lecture together. Per usual, we have our whiteboard, what I like to call the whiteboard, even though it's a Word file, with all of our assignments up and coming. Some due today, some due soon, some due a little later. So my math lab homework, 2.1, 2.2, 2.3 have all been finished previously, so no surprise on those due dates. Yes, we have my math lab homework. One or two of you have asked that via email. Please make sure you are always paying attention to these instructions. Of course, if you're not paying attention to the instructions, then this detail is overlooked, of course. All right, so 2.4 will be finished today, so it's due in 1 week, which is the 22nd. Excel files. And this will probably be the most we have on the board all at once throughout the whole semester, just kind of a back to back to back at the moment, because we're going to get to chapter 3 starting today, and we don't want to fall way, way, way too far behind on the more appropriate Excel assignments. Sure, I can give an Excel assignment from chapter 1 at the end of the semester, but it just doesn't feel like it fits in very well. So TV loan is due today. BMI is due the next class Thursday, and then currency is due a week from today. We're officially assigning currency. Remember that I said if you go in my math lab, I have eliminated all of the Excel assignments that in previous semesters students could see the 30, 40, 50 of them, or at least half of them. Y'all can only see the ones you're responsible for, so you can definitely tell which one is next. So if you go into my math lab and scroll through the chapter 2 stuff, maybe you'll see one for 2.4 called CPI, so maybe that's the next one that'll be assigned. I'm not telling you the due date yet, but you'll at least know what the next one assigned is. We do have that video quiz 1. Remember, that's technically our second quiz, but it's video quiz 1. That's in Canvas due today. Remember, that's based on my math lab videos. We're going to have about 3 or 4 of those throughout the semester, and they're kind of chapter based like video quiz 1 is. And remember, answer words, sentences, paragraphs, whatever you feel like doing, as long as it's an appropriate answer, as long as I can understand it, and as long as it's right. Do not just copy what the author says. Please do not plagiarize someone else's words, because we don't want to have to take any kind of negative actions there. We were assigned a discussion board last class, so that's due on the 17th. We'll be assigned another discussion board today, which is due on the 22nd. Remember, discussion boards are not long, massive assignments. They're pretty quick. And this discussion board right here, week 4, lecture 1, due a week from today, is the first one where every single student has an opportunity to answer this no matter what. And every single student must answer this one. This is not one where if you miss it because everyone else finished it, it's okay as long as you do the next one. No, everyone is able to do this one. So if you miss this one, especially if you miss the last one or the next one, you're gonna see your participation grade suffer, or well, you won't see it. You're keeping track of that, but you would have zeros, and we don't want zeros. So again, this is the first of many where I have made it so everyone can participate because I just have an iterative process. So you're going to see me talk about this later in the class today, in today's lecture, but these are the pages, and there's only like 5 questions. You might say, oh, well, that's only 5 students. Well, here's some additional info. You're going to hear me say, all right, the first 5 answers will go for age 25. So if you're the first student, you answer question 1 for age 25. If you're the second student, you answer question 2 for age 25. If you're the 5th student, you answer question 5 for age 25. Then when the 6th student comes in, they will answer question 1 for age 30. You just keep going through the same 5. Again, you only answer 1 question. If you're student 6, you're answering question 1 for age 30. If you're student 11, you're answering question 1 for age 35. If you're student 16, you're answering question 1 for age 40. So even if I had 1 million students, they could just keep answering. Every 5 students would just bump up the age by 5. Do not answer multiple ages. Do not answer multiple questions. And go in order. Do not just decide, hey, I'm going to answer age 40, question 3. No, you go into the discussion board, you see what's there. And okay, so someone just answered age 35, question 3. So I'm next, means I'm going to answer age 35, question 4. If for some reason you and another student answers the exact same time, not the end of the world. I'm not going to punish anyone for that. Everything is time stamped. If you answer the same question an hour later, that's a problem. If it's 2 minutes later, I'm not going to care. So again, this will be explained in great detail. Also, I believe it was when I was talking about this, I pulled up the wrong the wrong whiteboard. I pulled up a previous semester's whiteboard. It doesn't have any dates on it. Just it's very blank and generic. So just ignore that. Again, I'm not the best at recording things. I'm definitely not a professional. I'm kind of learning and getting better as we go. And a lot of the times I'm talking and focusing on the half of the screen that I'm supposed to be focusing on and don't even look at the other half. So maybe I'll bring ours up and try and cover it at that time. Not really going to be a big deal. Again, with this course, all dates, pay attention to what I say at the beginning, at the end. Occasionally, you'll see a wrong date in the middle of the lectures. And then finally, we are assigning a new quiz today. This quiz is going to be located in Canvas. And it's going to be, and this is probably the only one we'll do all semester, but it's going to be based off a couple questions from your guided activities, not the e-text, the guided activities, the stuff you see me using during the class. So it's page 101, and specifically it's question 4. So you could look at that now. We're going to see it during class, so don't worry, but I'm just going to say really quickly what it is. Find the answers to A and B. So you'll have 2 questions to answer, and the point is to find the value of A in this little proportion table and the value of B. Make sure you pay attention to the instructions. I am not going to be very generous with partial credit if you round to the nearest tenth when I said to round to the nearest whole. So again, the idea of paying attention is a very important concept in this course. Little details go a long way, and I want you to do as best as you can. You get 1 attempt on this, and I show you pretty much exactly how everything works in the class, so it shouldn't be any surprises here. But again, if you throw in a word when I don't say throw in words, that's wrong. If you round incorrectly based on how I tell you to round, then it would be wrong. So please pay attention, take your time. Remember, quizzes aren't timed, they're just due, and this is due a week from today on the 22nd. All right, so with that being said, we're going to pick up where we left off. In fact, I'm actually going to go back about 6 minutes. We had started introducing question 3 from that last discussion board, the what if analysis, kind of just assigning a top value and a bottom value, and then only playing with the top, only playing with the bottom. We never finished that problem. We only started the concept. And while in a perfect world, I could just say, okay, we just pick up exactly where we left off, I think it would benefit everybody if we just go ahead and start that problem back at the beginning from its entirety. Again, we're only going to lose about 5 or 6 minutes, so not a big deal. And let me stop rambling so we can get back to that. And again, this is a really awesome concept that for this what if analysis, it's not just important for talking about PE ratios. It can be important for talking about any concept that's a ratio. Miles per hour. How can you increase your miles per hour value? Well, you either have to decrease the top or increase the bottom or something like that. And I didn't say anything accurate there intentionally. I'm just saying that anything that's a ratio where you've got 2 different types of units, a rate, then you can talk about how that value ultimately goes up or down based on just looking at how the top changes or just how the bottom changes. Okay.
We're doing something known as what if analysis. This is something I mentioned that Excel is amazing for because we can just quickly type a number and see what happens. We can type another number and see what happens, or we can create an entire table of numbers and see what happens, kind of like that BMI table. Hey, if you're this weight and this height, what's your BMI? If you're this height and this weight, what's your BMI? If you're this height and this weight, what's your BMI? If you're this height and this weight, what's your BMI? It's the same idea as when we had that car loan where you're looking at like 5, 6, 7, 8, 9, 10% loans and taking that loan for 1, 2, 3, 4, 5, or 10 years or whatever that range was. If you do this, what happens? If you do that, what happens? So we're just going to play with a bunch of numbers at a time. For this particular problem, we are going to set up a fraction with numbers we choose. See what the answer is. Then, so this will be our baseline. So I'm just going to take 2 numbers and I'm going to divide them. Maybe 100 divided by 5 and I get 20. or 100 divided by 10, and I get 10. Whatever that number is, I'm going to hold on to it. That's going to be the thing I compare to every time. Then what we're going to do is we're going to take the top. So then we will play with the top. One time, make it bigger than the original top. One time, and I got to hit enter. One time, make it smaller. One of these scenarios, what we desire. What do we desire? We desire the PE ratio to increase. So let's ignore the whole idea of PE ratio. Let's just say we want the ratio to increase. We want the answer to go up. So what we desire is answer to go up. So we've just come up with our own two numbers, one for the top, one for the bottom. 100 divided by 5, or 100 divided by 10, or 1,000 divided by a million. It doesn't matter what they are. It's just a baseline. You get an answer, and you hold that answer, and you say, you're my baseline. You're what I compare everything to. Then you take the top number, make it bigger one time, see what the answer changes to. Make it smaller one time, see what the answer changes to. Okay, so that's scenario A. Scenario B is we'll play same way. And one of the scenarios is what we desire, to make the whole thing go up. Then make a statement about which things gave the desired answer and relate to PE ratio. So I'm going to start with two things. What's PE ratio? It's price and earnings. So I'm going to start with a price of, I said 110, so let's go with that. $100. And let's say earnings or profit for $10. This is just me making up two numbers. If this was normal class, you'd be in groups doing this. This does not bode well to a discussion board, unfortunately, so you're just going to see me do it instead. And I really don't like that, but it's something we need to see. But I would really appreciate it if all of you, which will end up being like 3 of you probably, and I just know that, if you tried this on your own, you, instead of using 100, maybe you say, I'm going to use 50. And instead of using 10, maybe you use, I don't know, 20. It doesn't matter. Come up with your own numbers. Sorry for that. So then our PE ratio would be 100, because that's the price, to the earnings, which is 10. And 100 divided by 10 is 10. And I'm going to put this in a different color. This is our baseline to compare. Yes, I know it's coincidentally the same as the earnings. Do not take that as any kind of important factoid. If you don't like those being the same, do 105 and then you'll have a 20. Easy way to fix things. So this is our baseline. So now what we're going to do is we're here. Then we're going to play with the top. So in this 100 over 10, I'm going to one time change the 100 to a bigger number. Then I'm going to one time change that 100 to a smaller number. So in a different color. So let's go with, so this is us playing with the top. Let's make it one time a price of, let's go smaller first. It doesn't matter the order, but let's make this the price 50 now. So that the PE ratio is now going to be 50 over 10. 50 divided by 10 is 5. How does that compare to the original baseline? 5 is smaller than 10. Is that what we desire? We want it to increase, so no. So that's not what we want. So that was making the price smaller. We went from 100 to 50. I could have gone from 100 to 99. I could have gone 100 from 90. I could have gone from $100 to $1. Don't think that that half the problem is figuring out what this number is. Just make a smaller number. Don't overthink it. And that's what everybody does in class in the group work. They go, well, I don't know what to do. Where'd you come up with the 100? How do I figure out what number it should be now? Make it up. We are making this up as we go by. All right, so this was me making it smaller versus the 100. Now let's make it bigger. So now let's change the price to, I don't know, $200. You could make it $300. You could make it $517.45. I don't care. Nobody cares. The point is, does the answer get bigger or small? So now we're not looking at any of this anymore. That's all done. The price is 200. The earnings is still 10. So we're doing 200 divided by 10, which is 20. Now, I'm not comparing to this. I'm not comparing to that. I'm comparing it to the baseline every single time. 20 is bigger than 10. So this was bigger. Is that the result we desire? Yes, it is. We were trying to make the PE ratio increase, which means bigger. So this is one of the scenarios. Making the top number bigger made the answer bigger. Making the top bigger makes the answer bigger. That's the conclusion for the top. Now let's do the bottom. So for the bottom changing, now we're not changing the price anymore, we're changing the earnings. Now the earnings was originally 10, so one time you need to make it smaller, one time you need to make it bigger. Mr. Beckner, what number should I make them? Should I make them 9? Should I make them 8? Should I make them 7? Yes, make them 9 or 8 or 7 or 3 or 1 or 0.02. I don't care. Make it smaller than 10 one time, make it bigger than 10 one time. Don't overthink this. Do something, don't stare blankly at your paper. All right, so earnings is what we're changing. Well, what do we make the price? Do we go with the 50 or the 20? We are disregarding, we are ignoring all of this now. We're going back to the baseline scenario. So we have to use the 100 for the price. So it's 100, I gotta write PE first. PE be the 100 for the price. That will not change in either scenario. Now one time, let's make the earnings smaller. Let's go from 10 to say 5. I'm just picking numbers that I know will divide evenly and quickly. 100 divided by 5 is 20. Now again, we're not looking at any of the red ink. You're ignoring that. You're just comparing the 20 to the baseline of 10. Is it bigger or is it smaller? Well, it's bigger, obviously. Now, let's make the earnings small. I thought I wrote the 5. I must have erased it accidentally. The earnings was 5. Shoot. There we go. Now, instead of going down in comparison to 10, let's go up. Maybe 15. How about 20? I like 20. Let's make the earnings 20. So that makes its PE ratio now. The 100 does not change, but the bottom does. The bottom changed to 20. 100 divided by 20 is 5, which in comparison to the 10 is smaller. Now ask yourself, do you feel, I'm just kidding. No, not do you feel lucky. Which one was it supposed to be? We were supposed to make the thing go up. So this was the scenario we wanted to happen, which meant we wanted the earnings to be going down in comparison to the baseline. So by making the bottom, and this is going to seem weird, but smaller, that's what makes the answer bigger. This is an extremely base idea of mathematics. When you have a division, if you make the top bigger, the answer is bigger. If you make the bottom smaller, the answer is bigger. So the top can increase or the bottom can decrease. And it's those two factoids right there that have everything to do with direct and inverse proportionality. Some people think we're done. We are not done. We have not actually answered the question, what are two different ways the PE ratio can increase? All we've done so far is said making the top bigger makes the answer bigger, making the bottom smaller makes the answer bigger. We need to use the appropriate words. We've got to be quantitative reasoning students. So what we say is, instead of saying by making the top bigger, what was the top? It was the price. And we're not just going to say by making the price bigger, we're going to say by the price increasing. That would make the PE ratio bigger. That's one scenario. Or the other way this could happen is by making the bottom, which we call earnings, or by the earnings or profit, aka. Give myself one more line. Oh, shoot. This is so frustrating sometimes. So by the price increasing or by the profits decreasing, the PE ratio can get bigger. Let's just say can increase. This is the ultimate answer to number 3. If the price per share of the stock goes up, then the PE ratio goes up. Or if the profit goes down, the PE ratio can increase. This statement shows you why there's kind of a sweet spot. So if your profits go down, your PE ratio goes up. What if your profits go down to like $1? Your PE ratio is going to be ridiculously high. But that's probably not a good thing, right? Because your company has only made $1 over the past year. You're probably about to bankrupt, probably. So that's why it sounds like you'd want your it sounds like you'd want your PE ratio to be super high, but not really, because it could mean that you've got low profits, or it could just mean that the price per share is just ridiculously high. So then you might go, oh, okay, well then I want the PE ratio to be ridiculously low, because if it's ridiculously low, that must mean that the company's got a ton of profits, because you're dividing by a big number to make it small. Well, that could be the case, but then the cost per share could also be proportional to that and just kind of cancel it out. So when your PE ratio is too low, it could be one of two effects. It could be that the price per share is way too low, which if you're in the penny stock range, you could be going out the window in a couple of days. Or it could be that your profits are ridiculously high, which is not a problem. So that's why there's kind of a sweet spot. All right, number 4, before we move on to the next page, make sure I got lots of space. I don't want that issue happening again. Compute the ratio of the dividend to the price per share and scale the second quantity to 100. So we're not scaling the second to 100, we're scaling it to 1. So number 4, the dividend to the price per share. We're doing dividend, use your words, to the price per share. So that's how we know what to set up. We're scaling something so we know it's a fraction equal to a fraction. The left one should be the dividend and price per share we extract from the table. What's the dividend? It's 1.72. Use your eyes. What's the price per share? It's 28.4. Use your eyes. Then we're scaling the second quantity to 100. Well, remember, when we scale things to 100, that's kind of turning one of these things into a percentage, basically. And then there will be our x. We're going to cross multiply. I'm just going to go ahead and show that 1.72 times 100 is 172. And then you'll get equals 28.4x. You will divide both sides by the 28.4. There we go. And then when we do that calculation, we will get a familiar number, 172, divided by 28.4. 6.05, blah, 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 blah. Let's just round this to 2 decimal places, so 6.06. So x is equal to 6.06. Now we scaled that to 100, so this is essentially a percent. Look at this right here. I mentioned this at the beginning of the problem. The dividend and yield were related to each other. So a dividend is based on a per share, whereas the 6.06 is if we were thinking of it as a percentage. It sounds a lot nicer as a percentage because when you see 1.72, you go, well, I mean, that doesn't sound like a lot. But 6.06 as a percentage does. But that's because this 1.72 is scaled to the price per share. When you convert it to a percent, though, you get 6% roughly, which again is a solid dividend. And you see a lot of the companies like energy companies and telecommunications that offer higher than usual dividends because they have money coming in constantly. Everyone's going to keep telecommunicating. We're going to keep using our internet and our cell phones. We're going to keep buying gasoline and fuel for our homes and vehicles. All right. Question 5, definitely not finishing this section, by the way, which is what I anticipated. The following graphic found in Peter Schiller's book, Irrational Exuberance, displays both the PE ratios for the entire stock market and long-term interest rates. What would you estimate the average historical PE ratio to be? So this is a table of information that's got two completely different sets of information on it. So the way that these numbers over here are scaled in comparison to these numbers over here, a human or a computer has made that choice. Now, especially when it's a human, they might make a choice to, maybe instead of this one being 18, maybe they want this to go up to 36 so that that graph is kind of shrunken in comparison to the other one. Or maybe they want this to be a height of 9 and have 18 all the way over here to make it seem more exaggerated in comparison to the other. When you've got scare tactics in the media, you see this all the time. I was looking at an article on the news the other day that had one of these. And if I can backtrack and find that article, I'll email it to everybody. But it had something where one of these things just looked like it was super, super scary. And you can probably imagine what I'm talking about. If you just look in the Virginia Pilot every day, there's a statistic, a graph that's up there. But not every day do they have both sections of it. Some days it's just one piece. Some days it's this other thing that kind of looks like this, and then it dips drastically. Anyways, there was a human being that shows how to scale those two things to each other to make that graph that they don't always show super scary looking. So that's one bad thing about having a chart like this, because there's choice made to, they wanted these two things to be at these scary high peaks. Maybe someone else goes, I don't want to intimidate people so much, and I want to have this blue one way up here and the red one down here for whatever reason. I don't know. It just depends on the problem and how evil the person or group of people are. Point of this problem. The following graphic, blah, 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 displays PE ratios, so those are in blue, and long-term interest rates that are in red. How can you tell? Look at the colors of the words. What would you estimate is the average historical PE ratio? So the PE ratios are based on the left numbers where it says PE ratio. So this is about a 20, this is about a 25, this is about a 32, 33, somewhere like that. Up here at 2000, it's about 45. Then we had the stock market crash of 2000, the internet bubble, all those tech stocks just went down really hard for a while, long while actually. And then we got some recovery. Interest rates, kind of in the 10 ballpark, then they kind of start dropping down to 5 in the 40s. And then they start spiking. Now, they started spiking in the 70s because of the fact that we went off the gold standard. So our dollar weakened immensely. So we went from having something known as inflation. The inflation rate went from like 4 or 5% on average to like 17% every year. So long-term interest rates kind of followed that. But then as things normalized, we got down to much lower rates on average. And now we're seeing really, really, really low long-term interest rates. Anyways, point of the problem. What would you estimate is the average historical PE ratio? We're not even looking at the red thing. We're just looking at the blue thing. Ignore the red thing. So here's what you're doing. I'm going to pull up a new, I got to go off of Annotate actually first. There we go. So let's do a new one of these. What I'm going to do is, this is the idea. They want us to find the historical average. And this is actually a concept, come on, that involves calculus. Well, you're not calculus students, and I'm not going to teach you calculus. What I'm going to teach you is how to eyeball things. So this I'm going to use as like a piece of paper covering something up. The idea is if I find the historical average, so if I put my piece of paper, I'm using the top of this border right now, so I'm putting this at a height of 25. The idea is that if I see the top half of this above 25, if I see roughly half of the blue ink, and then if I look at the below part of it, so now I'm covering up above 25 and I can only see below, if I see half of the blue ink, then that would be the historical average. So again, I'm trying to find the height at which if I look at the top, I see half, if I look at the bottom, I see half. So maybe you think that height is 40. Well, I barely even see any blue at all, so it's definitely not 40. And if you look at below it, so there's my 40, I see pretty much all of the blue. So 40 is too high. Maybe you think it's 10. So here's me only looking at above 10, and I pretty much see almost all the blue. If I look below 10, I hardly see any blue at all. So definitely not 10. If you look at 20, I see a decent amount of blue. That's not bad. That's not bad. I seem to see all the spikes, I feel like. If I look below 20, I don't know. I feel like I see a lot more blue below it, so I wouldn't say it's 20. And I'm not asking for you to go into 16, 17, or 12.5 or anything like that. Let's try 15. I look at 15, okay, now we're getting some blue above. Now we're getting some blue above. I see a decent amount above. This might be it. This might be it. So below. And I still see a decent amount below. Maybe a little less than what was above, but this is as close as it's going to get for us. That is absolutely as close as it's going to get. So the historical average is about 15. So this is saying about 15 for the historical PE ratio. So that's the magic porridge number that we were talking about, that we like our companies to be close to for that historical, they're going to have good long-term growth. It's not too crazy high consumer demand like Amazon or anything like that. Again, not the end-all be-all. Plenty of people have made millions off of Amazon, probably even billions, right? Definitely billions, in fact. Number 6, if a PE ratio rises, what seems to happen to long-term interest rates? This is not definitive, but they're pretty well related to each other, especially if you look at the long-term peaks and the extremes. So here's an instance where the blue is going down and the red seems to be going up. Here's an instance where the red seems to be getting ridiculously high and the blue almost bottomed out. Here's another instance where the blue goes super, super high and the red seems to start bottoming out. So based on kind of the peaks, I would say these are inversely related. So for number 6, what I would say is, as PE ratios rise, long-term interest rates tend to fall. It's not a definitive statement, but they do seem to be inversely related. And this is not the PE ratio of one stock. This is the average PE ratio of all major stocks. All right, like I said, this is one of those group work activities I really love doing in class. It does not work at all as a discussion board. And I tried doing group work the other day in another class, and I don't think it went very well, so I'm keeping to the discussion boards, as I may or may not have said recently. Okay. So we got a couple minutes left. Let's keep going with this. So all we've done so far is just this, but that is half the section, believe it or not. Maybe even a little more than half. Yeah, I'll say a little more than half. Okay. So CPI, this has nothing to do with stock. I don't want to say that. I don't want to say it has nothing to do with stock prices, because inflation can be an effect of stock prices. But this is just something completely different for us. Consumer Price Index. So one year you go to the store and you buy a loaf of bread and it costs $1, and the next year you go to the store and your loaf of bread costs $1.10, and the next year it costs you $1.25. One year you go to the store and you buy some hamburger meat and it's $4 a pound. The next year you go and it's $4.50 a pound. The next year you go, it's $5 a pound. One year you go to Starbucks and you buy your cup of coffee and it's $1.50. The next year you go, it's $2. The next year you go, it's $2.15. The next year it's $2.20. The next year it's $2.70. Prices increase. And prices don't just increase out of pure greed. I will say for a lot of companies, that's certainly a factor of it. But prices increase because we are constantly inflating as people. We are growing. We have more people every day, every month, every year. So because there's more people, and initially the dollars might not go up, there's less dollars to give to them, so there's higher demand for the dollars. So then we print more money, but by printing more money, we weaken the value of the dollar. So we make more people, we make more money, it causes the entire system to do what we call inflate in general. Not always. Stock crashes, really weird things going on historically, they can cause what we call deflation, where consumer goods actually go down on average. But when we talk about a CPI, we are talking about on average. So every year, these big group of, we'll call them nerds, they get together and they analyze the price of tons and tons and tons and tons of things in the market. And they look and say, all right, well, the price of fruit went up. All right, the price of meat stayed the same. Starbucks coffee went up. Oh, the price of milk went down for whatever reason. Because not everything goes up. Sometimes things go down for various reasons. Technology, those prices tend to go down. Think about 1995, a computer was going to cost you like $2,000. If you bought that computer nowadays, it would probably cost you 50 cents because it can't even do anything. But just in general, the price of computers as technology's gotten better have gone down. So better technology, lower prices. So technology kind of goes against inflation quite often. But again, inflation is looking at everything as a whole. So they'll say, all right, for 1995, the CPI number is 170, something like that. I'm just making up a number in the ballpark. And they'll say, all right, for 1990, the CPI is 130.7. For 2005, it's 195.3. I was looking at numbers for those. And that number is used to calculate the price of a good in 1990 versus 2005, or the price of a good in 2020 versus 2010. Now, if that good is priced exactly to inflation, then they would be exactly the same price ultimately. But again, quite often a good in 1990 is going to be more expensive or less expensive than the good in 2005, even when you account for inflation. Now, generally things go up. Generally, when you're comparing 1990 to 2020, almost everything will have gone up in price. Again, computers, technology, kind of the oddball there. But that doesn't mean that they went up proportionally. So what we're going to be doing next class is we're going to look at some things like, oh, a Starbucks cup of coffee in this year versus that year, or a Starbucks cup of coffee in Europe versus America. And they all use proportion tables. It's all the exact same thing we were doing at the beginning of chapter 2. It's fraction equal to fraction. It's cross multiplying. It's understanding that you can have gaps and that the gaps don't affect you. You just need 4 corners where 3 of them have numbers and the 4th is unknown. So we're going to be doing that next time. That is going to be what your quiz is going to be related to, but I don't want to spoil the problem yet. But we'll save that for next time. So
Terrible timing. Give me 90 seconds. Sorry, everyone. Hmm. Sometimes things in the real world are just timed poorly. I think y'all probably even heard my alarm just go off because something was happening here and it all happened a few minutes too early. Sorry about that. If you heard some information, saw some information you weren't supposed to see, again, just ignore it. Sorry, real life. All right, let's get back to where we're supposed to be.
All right, and you might, this might look a little different. I came back in and kind of did this again, or I think this is just an old file and it's about the same stuff, a little more, a little less. Don't worry about any things that you see up here that you didn't see before. We're going to talk about that. So we talked about all the PE ratio stuff. We very lightly touched on what CPI is. And I wouldn't even say lightly, we decently touched on what CPI is. It's a number that gives us a way of comparing the cost of something one year versus the cost of something another year. And what a CPI is typically used for, the way that number works is it's considering all goods available to the whole world, not just a gallon of milk or a computer chip or an Apple Watch or something like that. When you talk about one specific item, they usually don't scale exactly to what we call inflation. They may go up a little more, they may go up a little less. But the CPI gives us a way to determine whether something was cheaper in the past relative to what the dollar was valued at then, or if it's cheaper now / in the future relative to what the dollar is worth now. So a gallon of milk was, let's not even do the milk because it's on the screen. Let's say a ream of paper costs $1 back in 1990, and it costs $1.50 in 2020. And you could say, well, when was that ream of paper cheaper? And you might say, well, obviously it was cheaper in 1990 because it was $1. Well, no. When we say cheaper, we're also thinking relative to the value of the dollar. So yes, on an absolute level that really is not even anything we worry about, a ream of paper was cheaper in 1990 because it was $1 and it's $1.50 now. But again, we're thinking about the value of our dollar. The dollar was worth more in 1990. So it was a lot harder to get $1 to buy that ream of paper. But it wasn't like a lot harder, maybe 50% more difficult, maybe 100% more difficult. Just depends on how the inflation has happened over the last 30 years. And those CPI values give us a way of, again, accounting for that. So all items don't inflate equally, and that's what we're going to do some examples of coming up. For example, milk back in 2006 cost about $4 to $5 at the store for a gallon. And again, regular milk, not talking whole milk, not talking organic. Now in 2020, it's about $2 for the same, like $2.20, $2.30 if you're buying 2% milk. So that milk definitely did not inflate at all. In fact, it deflated because the dollar is weaker now after 14 years. It's gone down pretty much every year. Notice I said pretty much every year. It doesn't always go down. A computer back in 1995 cost $2,000, but now it costs about $250 if you just want to get a mediocre laptop that could still do a million things more than what that 1995 computer could do. So computer prices didn't inflate, and we were lightly talking about this last time. It was definitely much more expensive to buy a computer in 1995 because the dollar was stronger and it cost you more of them. So those dollars were harder to come by because they were valued more, and the sticker price is almost 10 times as much. So a weaker dollar means you're going to have more of them on hand, but that also means that the items generally, due to inflation, would be more. But these two items did not inflate. Then there are other things that inflate more than usual. Things that are typically, how do I want to say this? Fun things, they tend to inflate out of proportion. But fun things that aren't necessarily just technology. Like, let's say you wanted to go to Busch Gardens. That's a super fun thing that if you were to compare the cost of a day ticket back in 1995 versus in, let's say 2019, because who knows in 2020, right? Maybe they got 50% off all the time. Anyways, if you just did the day ticket, it was definitely going to be cheaper back in 1995, even with that stronger dollar. So inflation is different every year. Sometimes inflation is 2%, sometimes it's 1.5%, sometimes it's 3.9%. Sometimes it's negative, which means deflation, as we've very lightly talked about, happens occasionally. But due to us coming off of what we call the gold standard, A lot of people think that our dollar is backed by something. The theory now is that it isn't. It's backed by hopes and dreams. Up until it was the late 60s or the early 70s, somewhere in that ballpark. I don't have the data in front of me, but that was when we came off the gold standard, which meant back in the day, we used to have just a room full of gold, and if we wanted to print more money, we had to have more gold. That's the basic premise. So that gold was there just saying, all right, the dollar, if you wanted to just turn it in for a hunk of gold in I guess, Fort Knox or wherever, then you could in theory. Now they said, well, we don't want to just keep stacking gold in a room eventually, especially because eventually gold will run out. We will tap all of the gold in the earth eventually, as well as silver and any mineral like that. I'm not saying it's going to be in 5 or 10 years. It may be 100 or 1,000 years. That's not what we're here to debate. But because we came off of that standard, the dollar weakened extremely quickly. So we saw inflation, and again, inflation is what causes the dollar to weaken. I want you all to hold up, or at least imagine yourself holding up a $1 bill, and then inflation is you cutting off a small portion of that bill, and now it's only worth 98 cents or 98 or 97 cents. Or if you're talking in the 70s and the 80s when inflation was 10 to 15% every year, that means you're cutting off a dime to 15 cents of that dollar. So what you could buy, whatever you could get for $1 in, say, 1975, the next year, now that dollar is only worth 85 cents. You're not going to be able to buy the same thing anymore, again, across all goods, not just one particular good. This past decade, and actually the past 2 decades, inflation's averaged around 2 to 3%. We have the Fed that regulates that and tries to maintain that. Currently, right now, I know that's what's the word? I was redundant there. Currently, right now. So currently, we're actually, or the Fed is trying to bump up inflation because of everything going on, but let's not get into the greater grand details of that. It's some interesting stuff that you can look up, and if you don't like reading articles, you can find someone on YouTube rambling about it. If you are going to go to YouTube, though, make sure it's not one of the crazy people that are just making things up on the fly. Have someone that's, citing sources. You can find another video of someone else saying about the same thing. Because for every good person on the internet spouting truths, there's the opposite person somewhere. All right, so getting to the actual point of this, how we're going to use it in examples, how you can use it in the example in the real world, because you can pull up these CPI values. They're just numbers in a table on the internet. And very often you can find them in an Excel file. And one of your homeworks, clearly you probably can guess, you'll be doing something like that. So to be able to compare the price of a good from 2 different years, you must convert them to the same year's price. So the same year's dollar. So kind of like a US dollar and a euro has a different value, the dollar in 1995 has a different value than the dollar in 2020. So converting from a dollar to a euro is literally the same thing as converting a 1995 dollar to a 2020 dollar. It's not the same conversion values, but it's the same concept. And you know what that concept is? It's proportions and ratios. So we'll be looking at tables, we'll be drawing or imaginarily drawing boxes around numbers, trying to get 3 numbers in a blank in those corners. And that's the whole process. That's what I love about this course. We get to talk about a wide array of topics, but be able to keep bringing back the same simple mathematical idea and using it in a wide way, in a wide array, wide way, whatever. All right. Hint, in a CPI table, read across the row to compare the prices. So the row is usually the year, so that's you converting to the same dollar. So we will see this right now. So in a CPI table, in order to compare, you need a completed row. So you need to be able to see, all right, in a $2005, which thing is the lowest? That would be the cheapest. Or in a $1990, which thing would be the cheapest? And it doesn't actually matter which currency you convert to. One student could choose to convert everything to a $1995. Another student might choose to convert everything to a $2020. Because this idea of proportionality holds true. Remember, that's the way we're solving things. That means if it's cheaper in one currency, it's cheaper in the other currency. So just think if you were comparing an item in dollars to euros, and you compared several items in dollars to euros. Well, if you found the cheapest item in dollars, it would also be the cheapest item in euros. It's not going to be the cheapest in dollars and the most expensive in euros. That wouldn't make any sense. The cheapest in one is the cheapest in all. The most expensive in one is the most expensive in all. All right. So let's do this. Let's do this. I don't know why it opened that way. It's weird. Nope. We gotta go way past there. Here we go. All right. So getting down to brass tacks. The consumer price index, blah, 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 all the same stuff that we were just talking about. I'm not going to read it a third time. So this is what I was talking about for CPI values, and I made up some on the spot that were in the ballpark of this for like comparing 1950 and 2020. So 1990, the CPI value is 130.7. In 2005, it's 195.3. These values have the same idea behind them as saying it's $4 to get 5 euros. This is kind of that same idea. But it's not exactly that, because it's not like you're going to get $130.7 converting between these two. This would be converting back to whatever year the CPI was 1. So $1 back in probably like 1990. Why did I say 1990? 1900, because I'm looking at that year, that's why. So like $1 in 1900 would be $130.7 in 1990, and that's if the CPI of 1900 was 1. So again, we're just pretending the CPI in 1900 is 1. That means $1 from 1900 would now be worth $195.3 in 2005. Now, do we really need to think about going back to the $1 in 1900? No, absolutely not. No one does it that way. It's just the idea behind it. And again, you just draw a box, cross multiply, boom, that's all it is. So we have a cost of a movie ticket in 1990, and it was $6.50. Based on my memory, that actually seems a little high, at least in our area. Maybe New York City was that price, but either way, not the point. So they ask us, what would that cost in 2005, assuming that movie tickets went with inflation exactly? So set up a proportion to compute the cost of a movie ticket in 2005, which originally cost $6.50 in 1990. This is not saying that you're going to go to the theater and this is exactly the price that you see. We are taking the price from 1990 and we're turning it into a price from 2005. And then we could actually, in 2005, we got to get our time machine out, go and look at the movie theaters and see if they're above or below that, to see if they overinflated or uninflated. Or deflated. Why is it uninflated? So again, just drawing a box around that. Now remember, please remember, you are not doing this. This is completely wrong because these are labels. I know they look like numbers, they're labels. Don't you dare draw your box that way. They're labels. 1990 literally is just apple, 2005 is just orange. Your box is this. These are literally the only 4 numbers you can even draw a box around if you're drawing the box. So there's 3 numbers in corners and a blank, so that's our x. So we can cross multiply and solve from there. So we're going to go with 130.7 over 195.3 is equal to 6.50 over x. Give me 30 seconds. So we're going to cross multiply. So we get the 130.7 times the x is equal to the 6.5. I'm going to drop the 0 times the 195.3. Then we pull out our calculator, which is right here. Clear. So we're going to do 6.5 times 195.3. We're going to get 1269.45. So 130.7x is equal to 1269.45. Ooh, that got ugly. 0.45. Then we divide both sides by the number in front of the x, 130.7. And we can just do this divided by 130.7. And we get 9.7. Now we're talking money, so let's go 9.71. Let's round to the nearest penny. Generally with money, we're going to round to the nearest penny unless you're told otherwise. Now remember, the answer is not just $9.71, it's $9.71 because this was a cost of an item. So this would be the price in 2005 only based on inflation. Now again, I'm not saying this is the actual price. This is the price scaled by inflation exactly. Movie theaters could have chosen to charge a little more because they're high demand, they're high entertainment. Entertainment tends to scale more versus necessities. And the one thing I find interesting is that electronics have gone down over time, which says they're necessities. A lot of people years ago wanted to argue that these weren't necessary. The internet isn't necessary. Computers aren't necessary. Yes, they are. In this world, yes, they are. This isn't 1900. Computers are necessary, which is why they've deflated over time. Bacon is not necessary, so it is overinflated. Ribeyes are not necessary. They're delicious. So they have overinflated. So you go to the movie theater in 2005 and maybe it was $10 for the ticket, or maybe it was $9 for the ticket, or maybe it was $12 for the ticket. Obviously, prices are going to be different from theater to theater because they have different qualities. Some theaters are fancier, some are kind of run down and ready to be torn down. Back in 2005, I can think of one in Chesapeake that was in that kind of state that is no longer there. All right. Okay, so this problem was a CPI problem. The next problem we're going to do is a currency conversion. Now, we are going to focus in Chapter 3 on conversions. We will be doing problems just like this in Chapter 3, and it's literally going to be the same thing, but we can actually introduce it in Chapter 2 because it's just a proportion. I've already talked about this, in fact, and this was well, I swapped the numbers, in fact. I think I did $4 was 5 euros, but that's not a big deal. Hopefully there's no audio issues across the board. I just got a weird message. I'll try talking a little louder if that's necessary. It could be maybe just need to turn your volume up. I don't know. Let me know if anything happens though. And I know I've said this a couple of times, but if there's ever an issue with the audio live, especially if it's cutting in and out due to, quote, internet instability, which is the message I get, that the recordings are always fine every time I've looked at them. So you can just go back to YouTube to catch that section, because it's usually just a few minutes when that happens. And it's because I'm not the only one Zooming at home right now. So assume the ratio of euros to dollars is 4 euros is $5. So the opposite of what I said last time. Not that it matters. I said we had a stronger dollar. They say we have a weaker dollar. What is more expensive, a mocha latte that costs 2 euros or one that costs $3.50? So some people will say, oh, 350, that's a higher number. Well, no, they're not even the same currency, just in the same way that the movie tickets weren't in the same currency because we were talking about different amounts. Yes, it's still a dollar, but the dollar in one year is different than the dollar in another year, especially if you're looking at a large gap. So we have a 2 euro latte, the 2 euro latte, and then a $3.50 latte. Notice when they create the table, they did not sit them next to each other because that would not be the same currency. This is like the $1990. This is like the $2005. But we're not calling them those things. They're euros and dollars. So this is just current year, we could say. This is all 2020. Whether these conversions are the exact ones, please don't take it that way. It's definitely not the case. So the thing that we want to know is, they put the X here, but honestly, I'm going to write a Y here. Finding either X or Y gives you a way to compare. You can find either X or Y to compare. That's the note I gave earlier. Let me pull it up. Where all you have to do is just read across a row. I even have it currently highlighted. In a CPI table, you just read across a row to compare the prices. So they asked us to find, to convert the they asked us to convert the 2 euro latte to the American dollar. And then we're going to compare the price converted to the actual US latte. So this is like Starbucks in Europe versus Starbucks in America. In Starbucks in Europe, you're paying 2 euros. Starbucks in America, you're paying $3.50. Where is the more expensive latte? So you could convert the American latte to euros, or you can convert the European latte to dollars. It doesn't matter technically which one you do, but since they asked for X, we will find X. That is important for the quiz coming up, which we're going to see that question shortly. All right, so you imagine drawing your box, you might try and draw it this way. And this is a bad idea because you have 2 variables, so that means you can't do that. So that's a bad one. You might try and do it this way. And this is a horrible idea because these are labels. Now, these are actually that is the right number that goes here, but that's not the number that would go here. These are labels. They're not the data. That just says apple, that says orange, essentially. So no, you don't draw your box that way. The numbers are everything in this region. Now, if I drew my box that way, I drew my box this way, we've got number in a corner, number in a corner, number in a corner, and a blank. This is where I had the Y. Now, this would be a way of solving a proportion. You would be finding Y, and you would be able to make the comparison. But again, I want to do exactly as they ask, and we're going to find X. So that means I've got to draw it this way. See, I had to use the CPI values above to find that. These conversions, this 4 and this 5, those are just like CPI values. It's a base in one comparing a base in the other. So that's how we have to draw our box. So that would give us the equation 4 over 5 equals 2 over X. 4 over 5 equals 2 over X. Cross multiply, we'll get 4x is equal to 5 times 2 is 10. I'm not going to write the 5 times 2 because that's pretty easy. You're going to divide both sides by 4 to solve for x. And that tells you that x is equal to 2.5. Now x was right here, and that's in the American dollar. So it's $2.50. That says that the 2 euro, that looks like a cent. Why did I draw a cent? The 2 euro latte costs $2.50 in America. So the 2 euro latte would cost you $2.50 in the USD, not USA, USD. The undo button's killing me right now. Quit scrolling back up. So it's not saying that if you just transported that latte to America, it cost $2.50. The American latte, the one you buy from the American shop, was $3.50. So the 2 euro latte costs $2.50 with American dollars. The one in America costs $3.50. This is less than the 350 latte in the USA. So they asked which is more expensive. I'm answering which one's cheaper, but you just flip-flop it and you have the true answer. The one that's more expensive is the American latte. The American latte is more expensive because when you converted the European one to the same style currency, it was $1 less. So America's got that upcharge on the latte. No surprise. All right, I need to annotate and clear. There we go, off of annotate. So, same idea with number 3. And they're even going to keep the same base values of 2 and 350, but they're no longer euros and dollars. They're saying we had a $2 Starbucks mocha latte in 1990, which I feel like Starbucks was just starting up then, not that it matters, or a $3.50 Starbucks mocha latte from 2005. So now instead of comparing a latte from Europe versus America, we're comparing lattes in America one year versus another and seeing when was it cheaper to be buying these lattes when you consider all the different things in the world that you'd be buying, which is what CPI accounts for. So is it cheaper for you to be drinking lattes in the past? Well, I guess 2005 is in the present. The way back past of 1990 or the slight past of 2005. So, well, that's a $2 latte in $1990. See, everything's well labeled, $1990, $2005, the price in 1990, the price in 2005. We have the CPI values that you are not memorizing. I do not memorize them. I would look them up on a table. And once again, you could definitely call this blank a Y, and then you could compare this one to that one, the 2 to the Y. And you could definitely do that by cross multiplying. You would draw your box this way to get your 4 corners, and the blank would be the Y. But that's not what I'm going to do. I'm going to find the X, which means I need to draw my box this way. Again, if I'm actually drawing the box. Most people stop drawing the box after practicing this enough. So that's the proportion I'm going to set up. So we're taking the 130.7 over the 195.3 equals 2 over X. Now, remember, the proportion that I set up, I don't have to set it up this way. I could go 130.7 over 2 equals 195.3 over X. I could go 2 over X equals 130 over 195. There's 8, arguably 16 ways to set this up correctly, but there's also ways to set it up incorrectly. I can't go 130.7 over X equals 2 over 195.3, for instance. Cross multiply, you'll get 130.7 times X is equal to 195.3 times 2. Scroll down just a little. Oh no, I didn't hit enter at the beginning of all this. Classic rookie mistake, Beckner. So if I insert a page, it's going to do that. All right, so we're just going to start a fresh one. I'm going to hit enter a million times to make sure that that doesn't happen again. Word is an odd duck. We're going to rewrite our problem. 130.7 over 195.3 equals 2 over X. Cross multiply, you get 130.7X equals, I'm just going to go ahead and, in the interest of time, since you saw it written once at least, multiply 195.3 times the 2, and that's 390.6. Then you're going to divide both sides by, where's my draw? There we go. Divide both sides by 130.7. Give us X equals, divided by 130.7. We get X equals 2.988. So rounded to the nearest penny would be 2.99. Now that was $1. Now this is specifically the dollars in where? We're talking about the dollars in 1990. currency. When they write things this way, this 1990 and a dollar symbol, that's saying in the currency of 1990, the 1990 dollar. So the X is $2.99. So we just turned the $3.50 latte from 2005. We said, well, what would this cost if we bought it with $1990? It would cost us $2.99. Well, we want to know which one is cheaper this time, right? No, they said which one's more expensive. So which one was more expensive? Well, it's the higher one. So it's the 2005. So again, this X is now $2.99. So the more expensive one is the greater. All you're doing is comparing this number to this number and you're looking for the bigger one. That's it. That's all you're doing. 3.5 is bigger, so that says that the latte costs more in 2005. So that says that Starbucks has increased their price with inflation, but they've also decided to charge a little more on top of that. Now, maybe they're charging more because maybe coffee beans are more expensive. Maybe their employees are more expensive to pay for now. Or maybe they just want a higher profit margin. It could be a combination of all of those things as well. All right, so let's clear our screen. I just realized that the answer is going to go away. The latte in 2005 is more expensive. There we go. So this brings us to our quiz. Question 4, and that's on page 101. This is your quiz. Answer A and B. The same instructions we're seeing on your whiteboard. Page 101, find the answer to A and B. Round to the nearest whole number. Now, everything before I was rounding to the nearest penny because it made sense to do things that way. We're no longer talking about small dollar amounts. We're actually talking about billions of dollars here. So the penny wouldn't even be seen here. You would just be saying like a 0.3 billion. Just to make this as simple as possible for answers, so I don't get someone writing 195.3 instead of 195.4 and then missing 50 points on the quiz, because I'm not going to give partial credit for rounding on this quiz. You've got to be careful. Round correctly. Round correctly. Pay attention. Check it before you type it in. Don't rush. So all you have to do for this quiz is find the answer that goes here and the answer that goes here. Now you see two tables for this. You've got blah, 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 blah. This table is literally the same thing as the one that's part of question 4. These are exactly the same thing. Do not think you're answering two different bits of information. I also said you do not need to fill in any blanks to actually get this done. You do not need to fill in any blanks to get this done. So you do not need to get the answer here. You do not need to get the answer here. You do not need to get the answer here. And you definitely don't need to get the answer here. Now, yes, you could make the analysis that they ask you to do to determine the year when the receipts are greatest when adjusted for inflation. You could, instead of finding A and B, what some other student could do is find this and this, maybe they call them C and D, and then you could make the analysis to determine when the receipts are the greatest. So remember, you're just trying to complete a row, and wherever the biggest number is, that's when they were the greatest adjusted for inflation. But that's not the question I asked you to do for the quiz. I just want the numbers. I will even tell you the answer to this, not the answers to A and B, the answer to this question. When you find A and B, you should notice that the receipts from 2000 are the greatest when adjusted for inflation. So that's the middle column. So B should be the biggest number out of A, B in this 2154. I've spoiled that for you. So if you get the answers to A and B isn't bigger than A, guess what? You done it wrong. You done goofed. All right. So let me clear the screen again. All you're finding is A and B. Again, for actual analysis, you could have completed the top row or you could have completed the middle row. But I am asking, but I am just asking for you to answer A and B. Yes, again, this is the quiz. So find A and B. How do you do this? The exact same way we did the last 3 questions. It's the exact same thing as finding that theater converted to a new price. It's the exact same as converting the latte from one currency to another. It's the exact same thing as converting the latte from one year to another year. It's just you've got a scary amount of open space and stuff, but you're just trying to figure out how to draw a box where you'd end up with 3 corners that are numbers and 1 that isn't. Obviously, this is not going to get you anything because I've got 1 number in a corner and 3 blanks. So let me show you what one student would like to do probably. They'd like to do this. This is a box that would give you, this is an answer. I'm just going to write an X for a generic X. I didn't ask for that. Don't do it. Sure, you can. And again, then you could find this one in a similar manner. But that's not what I'm asking for. I only want A and B.
I'm going to have a couple weird edits here. So the first thing I just want to point out that this is the discussion board question that I mentioned earlier, which is on pages 102 and 103. Now, if you hear me say anything about start with age 35 then 55, that's wrong. I'm going to be trying to cover that. Again, when I made this recently, I wanted to do it this way, and now I want to do it a different way. But yeah, it's going to be a little easier, a little more consistent. So again, with this discussion board, we'll be starting at age 25 for the first 5 students, then going to age 30 for the next 5, then 35 after that. All right. So let's do this.
So the discussion board is going to be due on Monday. Remember, I did originally say that if I gave a discussion board on a Thursday, that they were going to be due on Monday. Multiplier or proportion value do it the more arduous way. How much money in the bank you have across your savings, your checking, your retirement funds, everything, not just one. So at 25, your capital to income ratio should be 10%. That's what's set. That is 10%. So capital income 10%. So what that means is, let's say you made $100,000 a year. That means when you're 25 years old, if you made $100,000 a year at 25, first of all, kudos. Second of all, it means that your capital, the amount of money you have set aside, should be 10% of that, which is $10,000. 10% of 100,000 would be $10,000. If you made $20,000 that year, that means you should have $2,000 set aside in the bank somewhere. Now these numbers get bigger and bigger and bigger and bigger as you get older and older and older, eventually to 12 when you're 65. Now you might be thinking, how am I supposed to have 12 times as much money set aside if I'm only making 1 times that? If I make $100,000 a year, how am I supposed to have $1.2 million set aside? Well, that's because it's not just taking the money you made that year, it's the money you've made for the last 20 or 30 or 40 years of working. So you keep adding to that pile and adding to that pile. And if you've got investments, if you're putting money away into stocks and bonds and you're getting 7% return on average, hopefully, knock on wood, then your money is going to start to explode eventually and really start working for you. And that's the goal. And that's what most Americans miss out on. is putting money away early, and having it just create more money on its own due to investing. All right, so when you're 25, you're supposed to be saving 12% of your income. So 12% of the 100%. So when savings to income, that's the money you're going to put aside that year. So if you made $100,000 a year at 25, that means $12,000 of that you should take and set aside and add to your pile in the bank. So you had $10,000 because of the capital income, and then by the end of the year, you would have set aside another $12,000, bringing you up to 22 by the end of that year. This mortgage to income ratio, this says that your mortgage that you go get could be twice what you make in a year. So if you made $100,000 a year, that means you would in theory be able to afford a $200,000 mortgage. If you made $100,000, that means that you could afford a $200,000 mortgage. I don't necessarily believe the mortgage to income numbers are a little accurate. They're a little low in my opinion, based on the fact that mortgage rates are so insanely low right now, but that will change later and maybe these become better multipliers. But for the point of the exercise, just go with it. Education to earnings. So this is saying that the amount of money that you have debt for from your schooling or your continued education or anything. So this is 0.75. So when you're 25, that means that you should have, if you made $100,000 a year, that means that you could have $75,000 in school debt and quote, be okay. And then by 30, you could only have $45,000. And then by 35, it's zero, which means you should pay off all your school debt by the time you're 35. Now, in reality, I know most people can't do that. We're not saying this is absolute end all be all, but this is what we try to mimic. At least that's the idea. All these X's afterwards, that means it's still just zero. You're not going to go back to school and acquire more debt. Again, just under a normal circumstance. Stocks to bonds. Oh man, I tell you what, in terms of my personal opinion, that is not financial advice. This column is complete trash. I don't think, again, my opinion, I'm more of an aggressive investor because I'm on the younger side, air quote younger, so older than probably most of y'all. But bonds are a safer investment that I just think you want more when you're in your 40s and your 50s. So in my mid 30s, I literally have 0 pennies in bonds personally, but that's not, again, not financial advice. I'm aggressive because I know I got plenty of time to make up any losses in the long run, but plenty of people are much safer investors than me. And they might go with this, all right, with my investments, the money I'm not using every day, the money that I put away and never touch again until I retire, half should be in stocks, half should be in bonds. And then eventually they say, all right, when you're really old, you want less in stocks and less in bonds. And please don't take that really old as offensive. Really, really old is not 60 or 65. We're all young at heart. Okay. So point of the exercise, questions 1 through 5.
All right, so I'm coming back in and just going to point this out. Question 1, it says you are 35 years old. Please ignore that if you are students 1 through 10 or 16 and up. Again, the first 5 students are going to come in and answer these for age 25. So student 1 answers number 1 for age 25. Student 2 answers number 2 for age 25. Student 3 answers number 3 for age 25. Student 4, student 5 for age 25. Then student number 6 comes in and they'll answer number 1, but for age 30. Student 7 answers number 2, but for age 30. Student 8 answers number 3, but for age 30. Student 9, student 10, and then student 11 comes in and answers number 1 for 35. Then 12 through 15, you get the idea. Student number 16 answers number 1 for age 40. Student number 21 answers number 1 for age 45. The pattern should be clear with that. So again, you can see the discussion board assignment here. 102 is where the chart was. 103 is where the questions are. You can see there is a 6th question, but this is really only just one specific age. And this is extremely open-ended. There is no accurate answer. So you could just answer number 6 on your own. Don't put it in the discussion board, but just think about that. By the time you were 65, what salary would you anticipate making? That is a difficult question to answer because we don't know what inflation is going to do over the next 10, 20, 30, 40 years. Yes, the Federal Reserve tries to keep it at 2%, but you just never know what's actually going to happen.
So hopefully there's no confusion there. I think I've made it clear enough. Let me get to where we should be.
Chapter 3. Definitely won't finish this section today, given that we have about 20 minutes left. But we will definitely start it. And I've already mentioned that really, I've already taught you how to handle half of this chapter, but I'm going to teach you another way that is better. As I always say, I like to teach multiple methods in this course because one method, method A, may be great for problem 10, and then you get to problem 13, and method A kind of sucks or is more difficult at least, but method B would be able to knock it out like that. Now, does that mean you have to learn both methods? No. If you just learn method A, then you can go with method A and you're just going to have a longer problem for that second one. But if you learn both methods and you understand that method A is going to take longer on the second one, you switch to method B and there you go. Boom. So units and conversions. So units are the things like feet or miles or inches or femtometers. Those are all distances. They don't have to be distances. A unit could be gallons, so talking about a volume of liquid. Or it could be hertz, which would be cycles per second, something we use for waves. So sound, when you talk about a sound wave, it's in hertz. It's one of the different units. And notice the first ones I said were all distance. I could say 1 mile, or I could say 5,280 feet, or I could say, hold on, give me a minute because I got to calculate it. I don't know it off the top of my head. Or 63,360 inches. So saying 1 mile is the same thing as saying 5,280 feet, is the same thing as saying 63,360 inches. Those are all literally the exact same thing, but with different units. So units are also like dollars versus euros, or 1995 dollars versus 2020 dollars. Those are all units. Now, in quantitative reasoning, it is extremely important to use your words, to use your units. That's why if you say, how far is it to the store? I'm going to erase this in a second. How far is it to the store? If you say 3, if that's your answer, that is terrible. 3 is not how far it is to the store. You're probably meant to say 3 miles, but maybe you meant 3 kilometers, or maybe you meant 3 nautical miles because you live on an island offshore of North Carolina or something like that. I don't know. But you have got to use your words. What's the temperature outside? Oh, it's 68 degrees. Wrong. It is not 68 degrees outside. It's 68 degrees Fahrenheit outside. Even just saying degrees isn't enough technically. Oh, how much liquid do you have in your cup? Oh, I have 8. No, you don't have 8. Oh, okay, I meant to say I have 8 ounces. Actually, no, you don't have 8 ounces. You have 8 fluid ounces in your cup. An ounce is technically different from a fluid ounce. I'm generalizing here, pretty much the only liquid out there that 8 ounces would be 8 fluid ounces is water, because its density is 1. We'll get into densities later, but we won't get too deep into them, pun intended. But if you had 8 ounces of syrup, that's probably like, I don't know, 7 fluid ounces, because ounces is a weight, fluid ounces is a measure of volume, and syrup is more viscous than water. Viscous means thicker, thick with 2 C's, and because it's syrup, and not the sugar-free kind, that nice, thick, straight from the tree in a barrel, whatever. Now I want pancakes. Okay, so those are your units. What's the whole point of this? Unit conversions. How do we go from miles to feet? and I erased the feet part on accident. How do we go from fluid ounces to another type of liquid measurement, volume measurement? How do we go from grams to tons? How do we go from miles to kilometers, if I didn't say that? Feet to inches, anything like that. Going between the standard US system, going between the US and the metric system, it's all the same. You can set them up as a proportion if you like, and you cross multiply to solve as long as 3 of the 4 spots are numbers, the same exact thing we've been doing. Now, how do you know how to set this up? You use your words. You would write miles over feet to start this, and then you put the numbers that you know the conversion factors for in one of them, and then the thing you know one of but not the other on the other side. Cross multiply solve. That's it. Or capitalized or, the thing that we'll be focusing heavily on because we've already done we've already done proportions over and over and over and over and over, you can use dimensional analysis. So the two methods of conversions are proportions or dimensional analysis. Proportions are great when you're just converting from one thing to another where you know exactly the conversion factor from one thing to another. So if I want to go from miles to feet, doing a proportion is not bad because I know exactly how many miles is exactly how many feet. But if I wanted to go from, say, feet to kilometers, that's not a very common number to see in just a general table. Sure, you can Google it, but that's not the point. In the table that we would provide for you in your homework or in your textbook, you would probably have feet to miles somewhere, and then you'd have miles to kilometers somewhere. So that would require 2 conversions, which is a little bit more of a pain in the butt because you would have to set up 2 proportions. You'd have to do a proportion going from feet to miles, and then another proportion once you had that answer going from miles to kilometers. So that gets annoying. Dimensional analysis, instead of doing a proportion to then do another proportion, is just multiply by something and then multiply by something. It's a lot less work, it's a lot less time, it's a lot less effort, but so many people just want to say bad things about dimensional analysis because they don't know what to multiply by. How do I know which thing goes in the top and which thing goes in the bottom? How do I know anything at all? Out with the old, in with the new. That's the whole thing. It's out with the old, in with the new. Out with the old, in with the new. That's dimensional analysis. That's all I would have to say in theory, but of course we'll say more. So it's a way of converting from one unit or rate into another unit or rate. Rates are just types of units, but they're fractions. So the main idea behind dimensional analysis is that you multiply your original value with the units in the proper spots as a fraction. So what I mean is, if I was converting miles to feet, if I had 3 miles, I write 3 miles. I do not just write 3. I do not just write 3. I do not just write 3. So I am going to highlight that because it's important. With the units in the proper spots as a fraction. So write the original number with its units, 3 miles, or whatever it might be. So you're going to multiply by a fraction whose numerator and denominator are the 2 values in a conversion factor. There are a very small amount of conversion factors I ask you to memorize, and they all have to do with time. I will not ask you to memorize any feet to miles or centimeters to inches, none of that stuff. Gallons to ounces, or fluid ounces, excuse me, I almost said that incorrectly. You don't have to memorize any of those. You would be given you're given charts in your homework problems. You could pull up your textbook for most of them as well. And if I give you a test, I'll give you the couple of conversion factors that you would need as like a formula sheet, if you will. Now, I say formula sheet, but that's literally all it'll be on your formula sheet. All the formulas we've taught you for the past 5 or so weeks, they're not on it. It's just conversion factors. So you multiply by a fraction where the numerator and the denominator are the 2 values in a conversion factor. What I'm saying is if you wanted to convert between miles and feet, you'd be multiplying top and bottom with these numbers. The top might be the 1 mile or the bottom might be the 1 mile. Top might be the 5280 feet or the bottom might be the 5280 feet. So how do you tell which one goes top and which one goes bottom? You must make sure that in the conversion factor, your old units are opposite their original placement so that they cancel. Also going to highlight that. Your old units need to be opposite their original placement so they cancel. By opposite, I mean if your feet were originally in the top, in your multiplier, put it in the bottom so they cancel. If your feet were originally in the bottom, then in the multiplier, put it in the top so they cancel. I don't even write any numbers at first when I figure out my multiplier. This is the first thing I do. I say, all right, what's my old unit? Feet. Where is it? In the top. So in the multiplier, feet have to go in the bottom so they cancel, and I'll be left with my new units. So before we get to this example, I said that I will not make you memorize most conversion factors. The only ones that I do ask you to memorize are time. All caps, you must memorize all time conversions. Specifically, the fact that 60 seconds is a minute, 60 minutes is an hour, 24 hours a day. Let me hit enter on that one just so it doesn't look wacky. And then 365 days is 1 year. Yes, it's 365.24 something because of leap years, and even leap years aren't exact. We do not have leap years every 4 years. There are years we skip leap years. We have a leap year. I think 3000, there'll be that leap year gets skipped, and there's some others like 3200 maybe. Don't worry about that. There are 365 days in a year for our intents and purposes. Please notice there's no days to months conversion. Yes, there's also 12 months is a year, but I don't want to type that because you might think that, oh, well, I can go from days to months and then months to year, and you can't. Because how many days are in a month? Well, January's got 31, February's got 28 or 29, March has got 31, April's got 30, et cetera, et cetera, et cetera. So there's no consistent answer. So we should not be using the days in a month to convert to months because there's absolutely no consistency. So these are the ones that you'd have to memorize. And I will guarantee you'll see one on the midterm. Now, I might just ask you to go from days to years. I may ask you to go from seconds to years. You could need one or multiple of these proportions or dimensional analysis setups. So we will, of course, go through all of those different types. Okay. Yeah, anyone who's got a birthday on February 29th, you're probably like 7 years old, I guess, if you're 28, right? That's the way you'll like to think, especially when you're in your 60s, I guess. That'll be the fun way. All right, so getting down to this. So this is a conversion factor. 1 mile is 5,280 feet. That's what we mean by a conversion factor. And I want to actually show the work process. So that was the typed up work if you saw it, but let's do this by hand. Let's say I said, all right, you went 0.75 miles. Maybe the distance from your house to the store, the grocery store, is 0.75 miles because you're right around the corner practically. I go, well, how many feet would that be? So to convert 0.75 miles to feet, sure, you could do it as a proportion. I'm not going to show you that because, well, I will, but let's do it this way first. You start with your highlighter. You start with your 0.75 feet, 0.75 miles, excuse me. So this is our original value. That's what we start with. The process is you start with your original value with its units in the proper spot. So there's our original value. And then we're going to multiply. We multiply by a fraction. That's dimensional analysis. What do you do with your number in units? Multiply by a fraction. What do you do with your number in units? Multiply by a fraction. Now, I'm not even going to look at this at all for the first second. Doesn't matter. I know that I want to go from miles to feet. I'm currently in miles. I need to get rid of them. These miles count as being in a top. See, that's in a top. If the miles were in a bottom, they'd be written something like that. There would have been a per in front of the miles, which can certainly happen. So because the miles are in the top and I want them gone, whatever number I'm going to have in the bottom, I know I have to put the miles in the bottom, so that way they will ultimately do this. They will cancel. They will go away. So I know I want the miles in the bottom. Now I can look at the conversion factor. See, I didn't even look at that at all to know miles go in the bottom. That's automatic. All right, well, the conversion factor says that 1 mile, ignore the plural s, that's okay, is 5280 feet. So where do I put the 5280 feet? Exactly in the place that's left. There's nothing to think about. That's it. That is dimensional analysis, and everybody makes it 1,000 times more complicated than it actually is. Miles top, miles bottom, units cancel just like variables and numbers. So you just multiply 0.75 times 5280. We can use a calculator for that. Now, before I hit enter, instead of asking, does it make sense when I get the answer, I want to predicate this and say, what type of answer do you expect? Do you expect this answer to be 10 million, 10,000, 5? Well, this is less than 1 mile, and a mile is about 5,000 feet. So if we have a number that's less than a mile, the answer should be less than 5280 feet. Probably not too close to 0 because it's almost a mile. But let's see what happens when we hit enter. We get 3960, and I would say that answer makes sense. Now, if you do this in a quantitative reasoning sense, it says wrong, 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 no points awarded. It's not 3960, and yeah, that's usually what you're just typing in my math lab, but again, the point is, outside of my math lab, writing pencil, paper, talking, units are important. 3960 what? 3960 apples? 3960 Bob Doles? 3960 feet. That would be the equivalency to 0.75 miles, and it does make sense. So I just have the same thing typed up here, as you can see. The miles cancel. Same way, and we get the answer. We see feet left, so that's it. Now, what I'll do real quickly, I'm just going to show up here the proportion way. How would you have done this? Well, you have to use your words first because you're going to ultimately set a fraction equal to a fraction. That's what we're going to be doing. But before I throw anything anywhere, use your words. What are the things we're converting between? Miles and feet. Which way do you want to do it? I'm going to go miles on top and then feet on bottom. That's my choice. Please, for the love of math, understand the abbreviation of miles is not M, it's MI. You will get answers wrong in your homework if you don't know that abbreviation. Maybe even a test ultimately. All right, so miles to feet. All right, well, use the conversion factor as one of the sides of the fraction. 1 mile is 5280 feet. Now, when we do proportions, we don't write the units. You can, but it's going to get ugly if you do. So 1 mile, I was saying that, so I had to write it. 1 is 5280. The reason with proportions that we don't have to write the units is because we're staring at the units right here by knowing what they are. Anything from the top is a miles, anything from the bottom is a feet. Then in our problem, we were supposed to be converting 0.75 miles. So where does the 0.75 go? Well, where the miles are, top. There's a 0.75, which makes that an x. You will cross multiply to get x equals 0.75 times 5280, which is literally the same thing we just did. It's 3960. Because x was in the bottom, we know it's feet. Now again, you might be saying, I love proportions. That way seems so much simpler. Why would I ever want to learn something new? Because learning new things expands your mind, and also these are not always that simple. If I asked you to go from feet to kilometers, for instance, you'd have to go from feet to miles, then miles to kilometers. Because most unit conversion tables can only give you so many things. Again, the internet can give you everything, but that's not the way the homework and tests and maybe even a quiz question at some point are designed. I say maybe, but honestly, it's definitely. We will have a quiz involving this at some point. Okay, so that was the way to do it as a proportion, still right answer. How can we tell that it's wrong? So let's say we did the dimensional analysis, and I'm going to keep this in red for the entirety. We have our 0.75 miles. I'll use orange, actually, for the multiplier. Orange is close to red. So everything I'm writing is wrong from here on out. So we take our 0.75 miles, and we know we got to multiply by a fraction. We're doing the dimensional analysis way again. So we're multiplying by a fraction, where it's supposed to be out with the old in with the new, but I'm not paying attention to Mr. Beckner. I'm not practicing. I just want to multiply and get this done. So I know, all right, we're going to use this. 1 mile is 5280 feet. Well, 1 mile is 5280 80 feet. There we go. We're rushing. All right. So what do we get? The 0.75 is in the top. The 5280 is in the bottom. So you're not going to multiply those two numbers. You're going to have to divide them. So we're going to end up taking 0.75 divided by 5280. And the number we get, wow, our calculator didn't even give us something that makes sense because this is in scientific notation. The e minus 4, what that says is take this decimal and move it left 4 times. So what that ends up being is, that's a 142. 0.000142. If you fix that number, this is what it is. The 0.75 divided by the 5280. I already think this doesn't make sense because we had 0.75 miles. We're converting this to feet, and 3/4 of a mile is 0.0001 feet. That's not even close to an inch. That is terribly wrong already. But here's another way we can tell that it's wrong. Let's actually pay attention to the units. Now, in the proper way, we had miles in the top and miles in the bottom. Anything top and bottom cancel. That's not the case here. These miles are both in the top. When you have 5 times 5, yes, it's 25, but think in exponents, it's 5 squared. When you have 7 times 7, it's 7 squared. When you have x times x, it's x squared. Units work exactly the same way. So miles times miles is miles squared. The feet unit is still in the bottom. So 0.75 miles is equivalent to 0.000142 miles square per foot. That makes, not mo, that makes absolutely no sense. It's got to be wrong. Not only is the number terrible because it's way too small when you think about it, the units are complete trash. They make no sense. I don't even know what a mile square per foot is. So if you do, please email me and tell me. Take your time, pay attention, use your units. If you don't write units along the way, you will make mistakes. Guess what? I've tried to do it that way at times. And I'm pretty good. I'll get them right, usually. But I definitely make way more mistakes when I'm rushing and I don't want to write my units and show the canceling and all that stuff. It is critical. All right, so that's all the time we have for today. So this was just a, we'll say, light introduction to this. When we come back, we'll do more of these. We'll also show you what happens when you have to do that middleman conversion, like I was kind of saying, the feet to miles to kilometers, where it would be 2 proportions, or it would be just 2 multipliers. But again, go ahead and practice these simple ones. Maybe try converting 2 feet to inches, because 1 foot is 12 inches. You should be able to do that pretty quickly. And then maybe something like, I don't know, since you've done one like this, maybe go with 3 miles to feet. That would be a good one. All right.
Okay, so that will be it for today. Getting y'all out in a timely manner as promised. Just putting that whiteboard up here for the last 30, 60 seconds of class. But again, you will see this at the beginning of class. And I wanted to mention something that I'll also mention at the top of next class. What is the calendar date? Thursday, the 24th, which is not this Thursday, but the following Thursday. So Thursday, June 24th, I'm going to be unable to hold class live. I have something going on that day that's unavoidable, and I could not schedule it any other time. So while I will not be able to hold class live, I will still have class completely prepared ahead of time. It will just be straight to YouTube. So you will not miss a single beat. You will still be responsible for viewing that material and knowing what's on your plate. It will be ready by the start of class time. So at 9 a.m. on Thursday the 24th, instead of clicking the Zoom link, as long as you've got your 2 hours, you can just go ahead and watch it on YouTube. Again, it will be pre-recorded. So I'll mention this again next time. I'll probably even put it on the little whiteboard. And yeah, besides that, per usual, if you have any questions, please email me. Sorry for that issue in the middle of class. Well, yeah, maybe not middle, like the first third of class. Like I said, sometimes home life is just home life. And that's half the reason why I do a lot of this pre-recorded material, because I got people and animals and stuff making all sorts of noise and coming and going and distracting. And yeah, like I said, I know y'all can sympathize because y'all have the same things going on. Cannot wait to be back in the regular classroom, so that's avoided. But for now, we make the best of it as we can. And yes, I also am playing around with the idea of making an open-ended discussion board just to kind of leave for people to maybe have a makeup assignment on that. But I'm not saying anything's concrete there, just throwing it out there. So yeah, again, any questions, please email me. Besides that, we will see you on Thursday. Make sure you complete all the homework that you need to complete, and take care.